Examples of polar coordinates. Plot the point P equal 2 comma pi over 4. Then find the representation of P that satisfies this condition. This point had the radial coordinate r equal 2 and the angular coordinate pi over 4. We start at the positive horizontal axis and sweep an angle counterclockwise and stop at the ray pi over 4 because the angular coordinate is positive. We then measure a distance of 2 from the pole to obtain the point P with the coordinate 2 comma pi over 4, where the radial coordinate is positive 2 and the angular coordinate is positive pi over 4. To obtain a representation for the same point where the radial coordinate is positive and the angular coordinate is negative, we will simply start at the positive horizontal axis and go clockwise. Notice that that angle is now negative 7 pi over 4. Thus, the point we need is 2 comma negative 7 pi over 4. We will start at the positive horizontal axis, go clockwise 7 pi over 4 to obtain a negative angle. Then from the origin, we would go out 2 units. We end up at the same final destination, P. To obtain another representation where the radial coordinate is positive and the angle is between 0 to 2 pi, well, this is the given point because r is positive and pi over 4 is an angle between 0 to 2 pi. To obtain a representation where the radial coordinate is negative while the angle is positive. To obtain the negative radial coordinate, we would first go to the opposite side of where we wanted to end up with. We want it to be in the first quadrant. To obtain the negative radial coordinate, we would first need to go to quadrant 3. But to get to this point in quadrant 3, we would need to add pi to this angle. Pi plus pi over 4 is 5 pi over 4. Thus, the point we end up with is 2 comma 5 pi over 4. But this point is in the third quadrant. To get the point we want in the first quadrant, we flip it over to the opposite side, but that is the definition of the negative radial coordinate. Lastly, to obtain a representation where the radial coordinate is negative and an angle is between negative 2 pi and 0, this means the angle has to be negative. In this case, we would go counterclockwise. But because the radial coordinate is negative, we would need to first go to the opposite direction. That is, we need to get to the point P prime so that when we flip it over, we will obtain a negative radial coordinate. But from the positive horizontal axis, to obtain the negative angle, we would need to sweep through an angle of negative 3 pi over 4. We end up with a point in the third quadrant with the coordinate 2 comma negative 3 pi over 4. Notice that the radial coordinate at the point in the third quadrant is still positive because we have not flipped it over yet. We then flip this point P prime over to obtain the point P, which is negative 2 comma negative 3 pi over 4. This representation locates the same point P. Observe that when we flip the point P prime over to P, we only change the radial coordinate from positive 2 to negative 2. The angular coordinate is still negative 3 pi over 4. Another example. Find the two polar representation for the point P -1, 1. It is always a good idea to plot the point first. X is -1, y is +1, so this point is in the second quadrant. In rectangular coordinate, this point has the x coordinate of -1 and the y coordinate of +1. In polar coordinate, the radial coordinate r is the square root of x squared plus y squared, which is the square root of 2. The angular coordinate is tangent inverse of y over x, which is tangent inverse of -1 or -pi/4. Keep in mind that this point is in the second quadrant, where -pi/4 is in the fourth quadrant. Thus, to obtain the proper angle in the quadrant 2, we would need to add pi to this to obtain 3pi/4, as it should be. The reason why we get -pi/4 in our computation is because tangent inverse is only defined between -pi/2 to pi/2. Thus, with the positive radial coordinate, the point we need is square root of 2, 3pi/4. With the negative radial coordinate, we would first need to go to the opposite side. The point P is in the second quadrant, thus we would first need to go to the fourth quadrant to get the point P prime. To get to the point P prime, we would need to travel 7pi/4 or -pi/4. If we start from the positive horizontal axis, go counterclockwise, that angle would be 7pi/4. But if we go clockwise, then the angle is -pi/4. We then flip this point over to the opposite direction. Thus, for negative radial coordinate, we can use either the negative square root of 2, 7pi/4, or we can even use negative square root of 2, -pi/4. Any of these representations has a negative radial coordinate as needed. Next, find a polar equation for the circle x squared plus the quantity y minus 3 squared equals 9. In polar coordinate, x is r cosine theta, so we replace x with r cosine theta. Y is r sine theta, so we replace it with r sine theta. Everything else is the same. This is r squared cosine squared theta plus r squared sine squared theta minus 2 times r sine theta times 3 plus 3 squared equals 9. But r squared cosine squared theta plus r squared sine squared theta, if we factor out r squared, then cosine squared theta plus sine squared theta is 1. So we have r squared minus 6r sine theta, and 9 minus 9 is 0. Factor out r, we obtain r times the quantity r minus 6 sine theta equals 0. Assuming that the radius is non-zero, we divide by r both sides of the equation to obtain r minus 6 sine theta. Thus, in polar, we obtain the equation r equals 6 sine theta. This equation represents the circle center at the point 0, 3 with the radius 3. Thus, r equals 6 sine theta represents the circle center at 0, 3, x equals 0, y equals 3 at the center of the circle with the radius 3. Another example, replace the following polar equations by equivalent Cartesian equations and identifying their graphs. Notice that the equations given are in polar r and theta, We want the equation in the form x and y, but we know that r cosine theta by definition is x. Thus, this is x equals negative 4. Identifying the graph, this is a vertical line, x equals negative 4. For part B, r equals 4 cosine theta. Remember that the substitute for x is r cosine theta, the substitute for y is r sine theta, and if we have x squared plus y squared, then we can change it to r squared. We have neither of those, but if we manipulate this expression by multiplying both sides of the equation, then we end up with r cosine theta on the right and r squared on the left. The r squared can be substituted with x squared plus y squared in rectangular coordinate, and r cosine theta is x. To identify the graph, we would move for x to the left-hand side of the equation and add 4 to both sides of the equation. We see that x squared plus 4x plus 4 is x plus 2, the quantity squared, plus y squared equals 2 squared. So this is the equation of the circle centered at negative 2, 0 with the radius r equals 2. Notice that to obtain r squared, we can square both sides of this equation. The left-hand side gives us r squared, which is x squared plus y squared. But on the right-hand side, we end up with 16 cosine squared theta, which is not useful for the purpose of replacing polar with rectangular coordinate, because x is r cosine theta, y is r sine theta, and x squared plus y squared equals r squared. With the purpose of changing polar equation to Cartesian equations, we want to have these factors to show up. We want to have r cosine theta to show up. We want to have r sine theta to show up, and so on. For the last one, if we rewrite this equation as 2r cosine theta minus r sine theta equals 4, then this is 2x minus y equals 4, or y equals 2x minus 4. And we recognize that this is the equation of the line with the y-intercept negative 4 with slope 2.